It feels like every few years, like clockwork, the same question pops up again in Jamaica. Should we be using container homes as a mainstream housing solution?
Uh,
And it immediately splits everyone into two camps.
it really does. You have the innovators on one side saying, look, this is fast, this is affordable. And then you have the seasoned professionals, the engineers, the architects who just see future liability.
Right. And the minute the idea gets any real political momentum, these professional bodies step in and they urge caution or sometimes, outright rejection.
Which, of course, leads to huge confusion for you, the listener. You see these glossy photos of really appealing, modern-looking homes.
And they look great, they look durable. But then you hear all these alarm bells from the technical experts warning about, corrosion, heat, structural failure. So where's the truth?
Well, that's exactly our mission today in this deep dive. We've been looking at source material from a professional with something like 20, 25 years in construction and project management.
And their goal isn't to pick a side.
Not at all. It's to move beyond the hype and the fear and bring some balance, some context, and some badly needed technical sense to the whole debate.
And they have this core thesis that just cuts right through all the noise.
It really does. They say the truth is actually quite simple, but it gets ignored. It's this. There's absolutely nothing wrong with container homes if they are done properly.
Okay, that's a big if, but it's a powerful statement of potential.
But then comes the other side of it, the caution that explains why all the professionals are so worried. There is absolutely everything wrong with container homes if they are done cheaply, lazily, or rolled out en masse without rigorous climate-specific standards.
Okay, so both things can be true at once. Let's unpack that. We have to start with the caution. Why are the professionals so quick to raise these red flags? What are they looking at?
Well, they're not just inventing these concerns. They're not being anti-innovation for the sake of it. They're relying on decades of historical evidence, specifically the failure of mass-produced, cheap, prefabricated homes.
You mean like the ones after World War II? To solve those massive housing shortages?
Exactly that. The classic example is the UK's 1950s prefab estates. They were meant to be quick, temporary fixes, but they stuck around for decades.
And became a huge problem, right? What went so wrong that we, sitting here in the tropics, need to pay attention to?
The problems were catastrophic, really, because they were systemic. These cheap, metal-clad units, they just suffered terribly from moisture penetration, condensation.
Because there was no proper thermal break.
No proper thermal break, no vapor barrier, so you got rapid internal mold, rot. They had terrible insulation, which made them freezing in the winter, boiling in the summer, and the ventilation was awful.
So just uncomfortable, damp, and expensive to live in.
And that was in a temperate climate. The real killer, structurally, was corrosion and fatigue. They were built to a minimal standard for a quick fix, not for the long haul. They became these huge, long-term liabilities.
A short-term solution that becomes a 50-year disaster.
Precisely. It cost the public a fortune to finally demolish and replace them.
Okay, that is a stark warning. And this is where it gets really interesting for us. How does the Jamaican environment, our heat, our humidity, our seismic risk, how does that amplify every single one of those historical risks?
It acts like a massive accelerant, a powerful one. I mean, just take heat. You have an untreated metal box under the direct Jamaican sun. That steel shell turns into an oven.
Literally an oven.
Without very specialized insulation and properly engineered airflow, the inside temperatures would be unlivable, dangerous even.
And the humidity, our relentless humidity.
Well, that encourages mold, rot, and the big one for any steel structure,
Right.
corrosion.
Yeah.
And you get it from two sides. Internally, you get that condensation, the sweating walls.
Right.
And externally, you've got rain. And crucially, especially near the coast, you have salt in the air. Salt-laden winds that just aggressively attack steel.
We're talking about atmospheric corrosion, where that salt is just eating away at the building year after year.
Exactly. If that steel isn't treated with really robust marine-grade coatings, its lifespan is just.
Yeah.
It's severely compromised. And that's before we even talk about hurricanes and seismic activity.
Which tests every single joint, every bolt, every weld.
And if the unit is only minimally reinforced, its ability to withstand those forces is, well, it's pretty much negligible.
So if you roll out a low-spec, poorly protected unit here, you are basically guaranteeing a very expensive failure within, what, a decade?
I think that's fair to say. So the professional's role isn't anti-development. It's genuinely anti-disaster. They're protecting all of us from the legacy of mass-produced units that are just doomed to fail under our climate stress.
That makes complete sense. But it still leaves that core tension from the source.
Yeah.
If the risk is that high, why does our source professional still believe so strongly that containers have a necessary place? Let's get to the defense.
Because the problem, fundamentally, is not the container itself. It's the standard you apply to it. The source is very clear on this. A shipping container is simply a structural steel box. Nothing more, nothing less. It's a raw material.
And we use steel all the time in traditional Jamaican construction. Rebar, roof frames, I-beams. We don't fear steel.
Absolutely not. The only difference here is the steel happens to be preformed into a box that once carried T-shirts or electronics. Nobody complains that steel itself is dangerous. The issue is when you treat that box as the finished product instead of the starting material.
Ah, that really puts it into perspective. The source has that great analogy. Saying a container is inherently dangerous is like saying cement blocks are dangerous just because somebody, once built a shoddy house out of them.
That is the crux of it. You can take the most traditional materials, cement, sand, steel, and build a catastrophically unsafe structure if your standards are low. The material is inert. Success is all about the human inputs.
Okay, let me play devil's advocate for a second, though. The source says it's just a steel box. But doesn't using a preformed box create its own problems?
Right.
You have to cut huge holes for windows and doors. Then you have to reinforce those openings. Isn't that actually more work?
That's an excellent point, and it's why containers aren't some magic bullet.
Yeah.
The initial saving you get from the free structural box is often offset by that exact engineering you mentioned. But the advantage is in its modularity. When you properly reinforce those openings, you retain the structural integrity for stacking and transport. That's what allows for fast, scalable, off-site fabrication.
I see. So the real determinants of success are all technical. If we just forget our fear of the metal box for a second, what are those determinants?
It's the specification, the design, the materials used, the engineering, and the craftsmanship. A container has to be treated, insulated, and reinforced intelligently. We have to stop arguing about the box and start talking about the blueprints and the certifications.
Okay, this brings us to a really critical point for you, the listener. The term container home is being used to describe two completely different products, and that's where all the confusion is. So we need to define the difference. The cheap stuff people worry about versus the quality stuff we should be considering.
That distinction is everything. Let's start with the low-end solutions, the ones that professionals are right to fear.
The disaster scenario.
Exactly. These are defined by shortcuts, minimal reinforcement, very thin or even non-existent insulation, maybe just a cheap layer of styrofoam glued to the inside.
And crucially, as you said, no thermal break between the steel and the interior walls.
Which means you get immediate condensation, the hot steel outside and your cool air-conditioned air inside. Water will just form inside the walls, leading to mold, rot, and internal corrosion fast.
So the source is clear. These low-end units are for short-term emergency use at best, not for mass rollout.
Absolutely. Now, let's contrast that with the real opportunity, the high-end solution. This is modern, high-spec, modular construction that just happens to use a container as its core.
So what are the non-negotiables? What are the specs that take it from a metal box to proper, durable housing?
First, mandatory structural strengthening wherever you cut the steel. Second, and this is vital for us, corrosion protection. We're not talking about a coat of paint. We mean a robust, industrial, marine-grade epoxy or a zinc-rich primer system.
The kind of stuff they put on ships or pipelines.
Precisely. Next is insulation. It has to be robust, fire-resistant, like a high-density closed-cell spray foam that gives you thermal performance and acts as a vapor barrier. And then you must have external cladding to shield the steel from the sun in the first place.
And what about cooling? It can't just be an AC unit fighting a losing battle.
No, you need integrated cooling strategies, engineered airflow, cross-ventilation, and often things like light-colored reflective roofing to reduce the heat load before it even hits the steel. And finally, of course, certified, hurricane-rated anchoring systems. That's non-negotiable.
So this is the key. High-end container housing is not cheap housing. It's specialized, high-spec modular construction. It might be cost-effective because it's fast, but it requires a serious upfront investment in quality.
That is the #1 takeaway. If someone is promising you a durable, climate-resilient container home for a rock-bottom price, they are almost certainly selling you a low-spec unit. Quality costs money.
Which brings us to the path forward for policy then. We've got this dual truth. The professionals are right to warn about low standards, but the policymakers are also right to explore innovative, faster solutions. The material isn't the problem, the standard is.
And that completely shifts the mandate, doesn't it? The conversation has to move away from should we or shouldn't we to what are the standards. The professionals are absolutely correct to demand rigorous regulations, independent testing, and long-term maintenance plans.
So instead of the public saying no to container homes, the demand should be, show me the specs, show me the engineering.
That is the practical application. If any developer, public or private, wants to pilot these units, the focus has to be on total transparency. We have to evaluate them on verifiable quality and engineering, not just on a slick brochure.
And the source gives us a perfect checklist for that. You, the listener, can use this. You demand to see the published engineering reports, the hurricane ratings, the insulation values, what specific material is it, the corrosion protection system, the maintenance plan.
And if they can't provide those certified details, the proposal should be rejected. Simple as that. But if they can meet those standards, then container housing becomes a really useful tool. Because Jamaica can't solve its housing needs with just one method.
We need a diverse toolbox of solutions.
Exactly. We need traditional block and steel, reinforced concrete, timber hybrids, light gauge steel, and specialized container-based units. Done right, they can be fast, energy efficient, and climate resilient. It's just another construction method, as long as the standards are impeccable.
It's fascinating. So this whole debate we see in the headlines, it's not really about the steel box. It's a proxy fight for quality control.
It's about standards and honest application. And the final distinction our source material leaves us with is about where the real threat lies. Container homes are not the threat to Jamaica's built environment.
What is?
The true threat is low-quality construction, poor planning, and a lack of rigorous enforceable standards no matter what material you're using. If we get the standards right across the board, then container housing can be one of the most practical tools we have.
That's a profoundly responsible conclusion, and it really makes you wonder how often fear or ideology gets in the way of just good, solid engineering and other national debates. Thank you for walking us through that deep dive.